Good evening, class. We are looking at section 2.7, derivatives and rates of change. We have looked at the previous six sections, and now here's the new one. Again, we covered the concept of a limit. The limit only exists if the one-sided limit exists. That means the left side and the right side are identical. Okay. We looked at the definition of a vertical asymptote. We looked at the definition of a horizontal asymptote. We did the intermediate value theorem as well as the squeeze theorem. So this is the synopsis of some of the stuff that were discussed. And now the derivatives and rates of change. Now, first, I want you to remember what's going on here, and that is the slope, okay, of a line, or in this case, a secant line. If you happen to have 2 points on a curve and connect them, it becomes a secant line. The slope of a secant line is very simple. Rise over run, okay? Rise over run. Change in y over change in x. Now, how do you represent that? There are many different ways of writing it, class, okay? So again, the good old way that we wrote, let me remind you. So we wrote y sub 2, remember that? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's what we've been writing. Now, if we represent this, okay, this is a, this is x, okay? So we represent this pair with a comma f of a, okay? And this one x comma f of x, okay? So y sub 2 minus y sub 1 becomes f of x minus f of a. And then x sub 2 minus x sub a becomes x minus a, or this distance. This is the run, this is the rise. Okay, this is x minus a, also known as delta x. Now, this distance can be represented differently. So let's also look at different method. This distance, class, if you call this, let's see, if you call this distance h, that's how we arrive at a plus h, okay? So that gives rise to this definition, okay? If the second point, class, call it b, let me use a different color. If you call it b comma f of b, that gives rise to this definition. What do I mean by that? They all mean the same thing. They all mean the same thing. They are all referring to the same thing, which is the slope of a secant line. Two pairs are given, okay? You can calculate the slope. Very simple. Now, what happens if we make, and by the way, another definition for h is delta x. Let me also write that. H also is the same as delta x, everybody, okay? Delta x. And this one, by the way, is known as delta y. Okay? Delta, change in y, change in x. And so if you draw different points and try to get closer and closer to P, in a limiting sense, you are getting to this line, red line, known as a tangent line. So slope of a tangent line, also known as instantaneous rate of change, is this limit. M of tangent line is the limit of PQ, okay, as Q approaches P, or limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus a over h, f of a over h as h approaches 0. All of them mean the same thing. All of them mean basically we are making this distance pass. This distance is delta x, or x minus a. We let this go to 0. This is the definition, okay, of an instantaneous rate of change. Okay. Now, I want to discuss the equation of a tangent line here. Okay. And the equation of a tangent line using the good old point slope. Let me write the point slope so everybody remembers that. Let's see the color they want to use. Let's go with this one. Class, everybody remembers y minus y1 equals m times x minus x sub 1. So I want you to look at this formula. This is identical to this formula. Instead of y sub 1, we are using f of a. Instead of m, we call it f prime of a. I can't emphasize this enough. Okay? So we don't want to be confused. We want to realize it's the same thing. Do I have to memorize the new one? Either way is fine. This is also called linearization, and sometimes when they calculate the y, they call it capital L, L of x, linearization. So the moment you hear linearization, it simply means find the tangent line. Okay. All right. The difference quotient, of course, going back again to that page, these are different ways of representing the slope. Okay, they all mean the same thing. And they were called the difference quotient. I hope you remember that. Sometimes they put x here, okay, f of x plus h minus f of x over h. You remember it from pre-calculus. Okay, this is the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of what? Okay, and that's the idea behind that, the average rate of change of y with respect to x. Now, instantaneous rate of change of y with respect to x is just taking this limit and letting delta x go to 0, or taking this limit and letting x go to a, or taking this limit and letting x sub 2 goes to x sub 1, or taking this limit and letting h go to 0. So why are we representing them differently? The point being they are all the same. What we normally use, class, are the following. We normally use this one and this. And I want you to remember that. Okay. Normally we use this. And so f prime of a, we basically approach it with these two methods. Okay. And we take it from there. All right. Let's look at an example to see how this thing goes. Okay, starting with a simple one. We want to find the average rate of change of f of x equals x squared minus 3x as we go from number 2 to number 4. Okay. And then the instantaneous rate of change at x equals 4. The first thing I want you to notice is the following. If you happen to have 2 points, even if they don't say average, that's what it means. On the other hand, if they have only 1 point, it means infinity. So the average rate of change is the good old basic slope, okay, which means the following. Okay, this is the average rate. So we're going to plug in 4 and 2. Okay, this will go very fast. Just plug in 4, evaluate it, which is 4 squared minus 3 times 4, and then plug in 2, 2 squared minus 3 times 2. Do the math, and you have the answer. That's the basic slope that you have. On the other hand, if we want f prime of a, we have now at x equals 4, we have two different ways of approaching them. So let's approach one of them, for example, if we take it this way. Okay. Now, this part without the limit, okay, is what we call DQ, difference quotient. Remember, we can have a, we can have x, you name it. So basically, we are going to evaluate this. Now, at this point, evaluation of this, it's all algebra. There are a lot of algebraic techniques involved. So just plug in a plus a and evaluate it. Okay. So what is a? 4. Okay. So we're going to put 4. You have two choices, by the way. You can plug in a and keep the a until the end and then change it to 4, which really becomes the derivative function, the next section, if you, or you can go with the number. Either way is fine. So if you plug in 4, okay, now what is f of 4 plus h? Let's plug in 4 plus h squared minus 3 times 4 plus h. That's what it is. Now, as far as f of 4, we've already done f of 4 here. This was 4, by the way, or you can evaluate it again, either way. So f of 4 plus h, and then f of 4. I hope everybody remembers the basics from algebra. So for example, when we have a plus b squared is a squared plus 2ab plus b squared. Okay. So this means what? 4 squared or 16, 2 times 4 times h or 8h plus h squared. The rest is easy. Minus 3 times 4 is minus 12. Minus 3 times h minus 3h. This is 16. Okay. And this is negative 12. Changes to 4 minus 4, or just apply the negative. It doesn't matter how you do that. The point being, just about most everything cancels out, and you want to pay attention to that. 16 cancels out negative 16, okay? And then negative 12 cancels out positive 12, which leaves us h squared and 5h. 5h, okay, class? So let's write that properly. So we have 5h left plus h squared. We can take the h out. Remember, when we have 0 over 0, it is the 0 in the denominator which is the problem. You drop the h, you're left with 5 plus h. Now, notice I have carried the limit in all steps. You cannot lose them, class. What you can do, you can simplify the expression, then use the limit, change the h. Now I can get rid of the h, replace it with 0, and it becomes 5. Okay? Replace it with 0, and it becomes 5. Okay? Okay, class, I hope everybody is comfortable with that. Now, I'm going to set up the second portion, okay? You don't have to do both ways. This is for the sake of illustration, and I leave it for you to finish it. Meaning, if you were to use this part, that means f prime of 4 is equal to the limit of f of x minus f of 4 over x minus 4 as x approaches 4. And so this would be the limit as x approaches 4. The numerator f of x is x squared minus 3x. Then f of 4, I hope you remember that f of 4 is 16 minus 12 or minus 4. Okay. And now it's just a matter of factoring, doing the job. Let's do that. So this is equal to the limit as x approaches 4. The denominator is x minus 4. The numerator is also x minus 4 times x plus 1, which is the limit of x plus 1 as x approaches 4, giving us exactly the same answer as expected. Again, do you have to do this both ways? Absolutely not, class. Why am I doing it both ways? Just so you see how it's done. That's all. And I highly recommend you practice with both to be comfortable with it. Okay. Here's another one. We want to find the equation of a tangent line, which means we need two things. We need a pair, and we need the slope. Speaking of the pair is given, class, but let's just make sure everybody understands what's going on in case the pair is not given. If they said just at a or x equals 1, you just plug in and you find the y, okay? So all they have to do, give us the x coordinate, we can find the y. So we have the pair. The next thing is to find the slope. To find the slope, we have to use one of these definitions and get to the slope. So, for example, we can use this definition. Again, it is absolutely up to you, class, what definition you use. Unless you're asked, then you want to follow that. So f of x is very clear, it's x squared. And remember what we want. We want f prime of what? 1. Again, we can keep it as a and eventually change it. We want f prime of 1, so let's change the a to 1. Okay. All right, so f of x is x squared minus f of 1. We already have it, or plug it in. F of 1 is the y coordinate, which is 1, so you write it down. This makes it very easy because I hope you realize this is a very easy factoring. The numerator becomes x plus 1 times x minus 1. So you can drop the common factor of x minus 1. And now you plug in and you get to 2. And practically you're done. You have a pair, 1 comma 1. You have the slope. So you're going to use y minus y1 equals m times x minus x of 1. The point slope, okay? Instead of writing y minus f of a equals f prime of a times x minus a, that's the same thing. And again, let me just quickly write at top of it so you see what we had there. So they would write y minus f of a equals f prime of a times x minus a. That's the same thing, everybody. Okay, that's the same thing. Okay. All right. And so we come up with the answer. Y equals to x minus. By the way, class, the pair belongs to the original function, so it should satisfy that. Also, should satisfy the tangent. Just quickly, and for the sake of argument, because I want you to be exposed to it, what about the second method? Let me just quickly go over that for you all. If we were to go with the second method, okay, which is more popular, you replace the a with 1. Okay. And so what is f of 1 plus h? That means 1 plus h squared. And this one, I hope you remember, it's 1 squared, which is 1 plus 2 times the first times the last 2h plus h squared. So 1 and negative 1 cancel each other. And the numerator, we can factor out the h. Remember, the h in the denominator, which is 0, is a problem, and we are hoping to get rid of it. And now we can. H drops out, and you're left with 2 plus h. It's important to keep up with the limit. Otherwise, your answer would be 2 plus h. If you don't have a limit, this is 2 plus h. Now, because you have the limit as h approaches 0, you take it to 0, and it becomes 2 plus 0, or simply 2, and that's exactly what we had here. Of course, the second part, which is an easy elementary algebra part, you do. Let's look at more examples. We are interested in finding the equation of a tangent line for this case, f of x squared of x, and the pair is given. By the way, again, they might say just x equals 16. If you plug in, you get square root of 16, which is 4. They might say, what about that x equals 100? Okay, just in case, because I want to make sure everybody understands. They don't have to give us the pair. If they said at x equals 100, I hope you see that it's 100 and square root of that, which is what? 10, meaning if x is given, you should be able to come up with the pair. And that's my point for this part, okay, everybody? So again, I cross it out, meaning it's got nothing to do with this question. I just wanted to explain how you arrive at the pair in case the pair is not given. So let's go with the definition. Any of them will do the job, okay? So if we stick with this definition and replace the a with what number? Number 16, okay? So we replace this with 16 plus h, and then you have a choice, class. For f of 16, you know the answer is 4. You can use that, or you can just write square root of 16, just in case. It's not given, okay? For that reason, that's square root of 16, but you know, and of course, you know square root of 16. But no matter what, you have 0 over 0 if you plug it, which means it's an indeterminate form, which means you have to use your algebraic technique to fix it. The algebraic technique you all have seen many times is multiplication by the conjugate. So you multiply by the same thing, you change the negative to positive, and you have it for the top as well as the bottom. So what happens to the bottom, and that's important, you keep it intact without a change. It is a product of these two. The top, this comes out, minus this comes out. So 16 cancels out negative 16, you have h, and the denominator is in the form of a product. So h drops. See, I'm still keeping square root of 16 as square root of 16 instead of 4. That's okay, class. I just want you to see what happens. So h drops, and now what? Now I can replace the h with 0. I get 4 here, I get 4 here, 4 plus 4 is 8, I get 1 over 8. The rest is history. Y minus y1 equals n times x minus x of 1. I can't believe anybody having any problem with that. So replace them, do the math, okay, and you come up with the answer. By the way, I hope everybody knows this. 1 over 8x minus 1 over 8 times minus 16 makes it 2, and you need to add 4 to both sides, okay? You need to add 4 to both sides. So that's a basic elementary algebra. I don't believe anybody has any problem. So here's the next example. We want to find the distance in feet of an object from a starting point, where s of t is given, okay, class, as 2t squared minus 5t plus 4d, where t is time in seconds. What is the velocity from 2 to 4? We're looking at the good old average rate of change. So plug in 4, plug in 2, do the math. It's really not a big deal, as we have seen before, okay, class. So I hope everybody is comfortable with that concept. So the average rate of change, okay. In essence, is very similar to question number 1. You plug in, you do the math. Don't forget the proper units. Whenever you do word problems, proper units, I can't emphasize this enough. This is elementary algebra. Plug in. The velocity is total distance over total time. Done. Okay. Now, what is the instantaneous velocity? Okay. Now we can use this formula, okay, where a is simply whatever is given. In this case, is 4. Okay. All right. So we use this formula, and a is 4. Everybody. So let's plug in 4 now. This is the part that is important. You want to be very careful with your accounting. So 2 times t squared, that means 2 times 4 plus h. Minus 5t, that means minus 5 times 4 plus h plus 4. Minus s of 4, you just plug in 4 and evaluate. Okay. Now, quickly, if I want to write some stuff here, this would be 16, right, plus 8h plus h squared. So you have to multiply that by 2. So you get 32 plus 16h plus 2h squared. The rest is easy. You can easily see the calculation. This is minus 5 times 4, or 20, minus 5h plus 40. This is 16 times 2 is 32, minus 20, plus 40. Okay, so this is plus 30. So this becomes minus, we can say minus 32. Okay, plus 20, and then minus 40, which cancels out all those numbers. I hope you see that. And then 16h. So in other words, 32 and negative 32, okay, 40 and negative 40, 20 and negative 20, and then 16h and minus 5h is 11h, and you have 2h squared, you take out the h. So we have, in other words, we have 2h squared plus 11h left from the numerator. I hope you see that there's a lot of algebra involved, but calculus, not a big deal. You don't have a lot. Now, you drop the h, and the moment you take a limit of, this is the piece class, when you take this limit and you end up here, this is really your calculus. Everything else, writing this expression, okay, although this is in essence calculus, but writing it is all algebra. So there's a lot of algebra involved. There's a lot of algebra. Okay, so here's the next one. We want to find an equation of a tangent line to the graph of this function, y equals g of x. At which point, at x equals 5, so one equation of a tangent line, we know g of 5 is given as negative and g prime is given as 4. So how do we arrive at it? Okay, very simple. You want to come up with the equation of a tangent line. Okay. So what do you need? You need a pair x comma y, and you need the slope. Okay, so we need a pair. And so is the pair given? Take a look. G of 5 equals negative 3. That means what? When x is 5, y is negative 3. So this is your pair, everybody. At x equals 5, g prime of 5 is 4. So that's your slope. Now, y minus y1 equals m times x minus x of 1. The rest becomes elementary algebra. The point of this question, can I recognize my pair? Okay, so quickly, this is the pair. G of 5 is negative 3. That means 5 comma negative 3. And this is the slope. Now you plug in and you do the math. I wouldn't worry about that. I assume everybody can easily finish it. So y minus y1 equals m times x minus x of 1. Plug in and you are done. Okay. Here's another interesting example. If the tangent line to this function, y equals f of x, at this pair, 4 comma 3, passes through this point, can you tell us what's f of 4, what's f prime of 4? Okay. So we want to find f of 4 and we want to find f prime. Okay. First and foremost, f of 4, look at this pair. 4 comma 3 is given. So f of 4 is 3. The pair tells us what's f of 4. The pair 4, 3 tells us that, f of 4 is 2. We know that it goes through these 2 points. So class, what do we have? We have 2 pairs, right? The tangent line goes through 2 pairs. Calculate the slope, becomes f prime of 4. So what is f prime of 4? The slope of that. So first and foremost, 4, 3, that means f of 4 is 3. Secondly, we have 2 pairs, calculate the slope. It gives you the slope of a line containing those 2 pairs. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and you come up with the answer. It's pretty straightforward. I hope everybody understands what's happening here, okay? All right. Each limit represents the derivative of some function f or g, or whatever you want to call it. We want to come up with that function f of x, and we want to come up with a. This is just done by inspection. There is no more, no less. There is not much involved, class. So what you have to do, look at your definition of f prime and choose the one that pertains. I hope you realize as you look at the question, it pertains to the first one or the second one. Basically, do the comparing, okay? So this is f prime of a, and it looks like the second one as an example. So you write f prime of a is what's given, and f prime of a is this limit. Are you with me? You put them just next to each other and you make a decision. There's really not much except inspection, okay? So you have some f of x where f of a ends up being 3, so because it's minus that. And this is f of a plus h. I hope you see by inspection, f of x becomes square root of x, and a becomes 9 because square root of 9 is 3. So this is just by inspection. There is really no way around that. You have to compare and contrast and figure out what happens. So by choosing f of x equals square root of x, okay, and therefore a plus h, this is a plus h becomes 9 plus h, a becomes 9, and then you check, is square root of 9, is f of a equals 3? Yes, it is. Here's the next one. Again, this is f prime of a, and compare it to the same thing. This is f prime of a, so write this as f prime of a and write the one that pertains. Is it the first one or the second one? It is the second one. Looks like the second one. So this is f of a plus h, okay? And this is f of a, okay? So by inspection, there seems to be that f of x is 2 to the power of something. So 2 to the power of x, and then a plus h is 3 plus h, which means a must be 3. Now, does it make sense? Check it out by putting it into f of a. So f of 3, is that 8? Yes. So after you do it by inspection, then plug in, make sure it works. It's just inspection, class. There is not much to it. There is not much I can really explain other than it is inspection. Here's another one, which we are going to do by inspection by putting this one as f prime of a. Again, looks like the second one. So let's put them next to each other. So we have f of x such that f of a plus h is e to the power minus 2 plus h, and minus f of a becomes minus e to the power of minus. I think it becomes pretty obvious that your function must be e to the power of x. So if the function is e to the power of x, then minus 2 plus h is a plus h, okay? And making a to be negative 2. Does that make sense? F of a, that means e to the power of a, and if a is negative 2, that works. So far, everything looks like the bottom one. But if you look at this example, okay, now it looks like, and we call this f prime of, by the way, use the proper variable. This is f prime of now theta, okay, f prime of theta, and looks like the top one, okay? So it looks like a top one. If we compare it to this, of course, this has to be done to change to f of theta, okay, class? This really should be changed to theta. This should be changed to theta. This should be changed. But it's okay. We are comparing. We are comparing. That's okay. So as it appears, this should be your function. So f of theta is sine theta. If it was sine x, class, we would say f of x is sine x. So f of theta is sine x. And what about this one? X minus A, that means theta minus A. So theta minus A, so A must be pi over 6. Now, does it make sense? Well, is sine of pi over 6 1/2? So by inspection, if we go with sine theta, f of theta equals sine theta, and A is pi over 6, does this work? You look at sine theta minus sine of pi over 6, which is 1/2. Everything works out. We are in good shape.